You already know how to derive a Boolean logic equation from a truth table and how to derive a logic circuit from a Boolean equation. Now let's start with a story problem. In real life, all engineering problems are really story problems. Here's a story problem. 3 board members vote on corporate policies. Their names are Adams, Baker, and Cheney. If 2 or more of them vote yes, the policy is implemented. Create a Boolean equation. Well, the first thing you do when you have a story problem like this is to create a truth table. The inputs are A for Adams, B for Baker, and C for Cheney. The output is P for policy. Next, we want to create all the possible inputs. So we start at 0 and count in binary. Until we get all the way to 7. And then we go back to the story problem and read it again. If 2 or more of the inputs are true, meaning they voted yes, the policy is true, meaning it was implemented. So let's find all the places where 2 or more of the variables are voting yes, or where 2 or more of the variables are true. That's not here, so that's a 0. That's not here, so that's a 0. That's not here, so that's a 0. On this line, B and C are both true, so the output is also true. On this line, only A is true, so the output is not true. Here, A and C are both true, so the output is true. A and B are both true, so the output is true. A, B, and C are all 3 true, so the output is true. So that's the truth table that satisfies that word problem. The rest of it you already know how to do. You can create a logic equation from a truth table. Let's do it again for practice. P equals all the places where P is true. Well, that happens here, 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 and here. That means there are going to be 4 terms in our logic equation. The first one is A naught and B and C. Or the second one is A and B naught and C. Or the third one is A and B and C naught. Or the last one is A and B and C. Let's draw the logic circuit for that logic equation. We need 4 AND gates. And all the AND gates are going to be combined into one OR gate. The output is P. This AND gate has 3 inputs. This one has 3 inputs. This one has 3 inputs. And this one has 3 inputs. The inputs for the first AND gate are A naught and B and C. The second AND gate has A and B naught and C. The third AND gate has A and B and C naught. And the last AND gate has A and B and C. Of course, we only have 3 inputs, A and B and C. So all of the A's connect to A, and all of the B's connect to B, and all the C's connect to C. But we need to have an A naught, so we'll create that with a NOT gate. And we need to have a B naught, so we'll create that one with a NOT gate. And we need to have a C naught, so we create that one with a NOT gate. And of course A naught goes to A naught, and B naught goes to B naught, and C naught goes to C naught. And that's the logic circuit that goes with that logic equation, that goes with that truth table, that is a result of that story problem. Here's another story problem. This one is a little more technical. A factory processes a liquid in a tank. There is a sensor for the fluid level called L, one for the fluid temperature called T, and one for the fluid pressure called P. An alarm called A must sound if the temperature and pressure are both too high or if the fluid level is wrong. Create the Boolean equation. Once again, we start with the truth table. We have inputs L, T, and P. The output is A. All the combinations of input go from 0 to 7. The alarm sounds whenever the fluid level is wrong. That happens here, and here, and here, and here. It also sounds if the temperature and pressure are both too high. That happens here and here. But remember that if we have a 1 already in the truth table, we don't need to duplicate it. So we'll take that second one out. Everywhere else, the conditions are not true, and the alarm will stay silent. Let's derive the equation from this truth table. A equals L naught and T and P, or L and T naught and P naught, or L and T naught and P, or L and T and P naught, or L and T and P. That's the logic equation for that truth table, which matches the word problem. In another class, you're going to learn how to simplify that equation and make it much shorter. With this particular word problem, we can find a shorter version just by examining the word problem itself. It says that the alarm must sound, or the alarm will be true, whenever the temperature and pressure are both high. That would be T and P. Or if the fluid level is wrong. So reading right from the word problem, we get a much shorter equation that reads A equals T and P, or L. Once again, that shorter equation is equivalent to the longer equation, and you'll learn how to do that in another class. Let's draw the logic circuit for the shorter equation. We need inputs T and P and L. T and P are going to be ANDed together, and the output of that AND gate is going to be ORed with L, and the output for the entire circuit will be A. So this word problem gave us this truth table, which gave us this equation, which we could simplify to this, and from that equation we got that circuit.